Hi, in this video we will look at some proofs with absorption. Hi, this is Logic Self-Taught with Dr. Phi. In this video we will do two proofs with the absorption rule. Try to do them on your own. If you have problems or just want to check the solutions, keep watching. Absorption is our last inference rule. It allows us to infer a conditional from a conditional. Given a conditional on its own line, we are allowed to infer another conditional with the same antecedent but a more complex consequent. The consequent of the inferred conditional is a conjunction of the antecedent and the consequent of the original conditional. Consider the first proof. It has 4 premises and a relatively simple conclusion. We proceed as usual. We look where we can locate k in the premises. We find k in premise 4. It's a disjunct. We know a rule that would allow us to derive a disjunct. We will need the negation of the other disjunct, and we'll be able to derive k by disjunctive syllogism. So we will try to obtain not m. Not m is in premise 3. It's a consequent of a conditional. We will be able to get it by Modus Ponens if we can match the antecedent. In this case, we would have to get if A, then C. And now if you look at premise 1 and 2, we see that we have 2 conditionals in these 2 premises with the antecedent wanted and the consequent wanted. But unfortunately in this case, we can't match the middle term. The consequent of line 1 is B, the antecedent of line 2 is A and B. But we have a rule now called absorption that allows us to derive a conditional with a conjunction in the middle. And this is the point where, if you've done the rule application exercises, your eyes will see the opportunity to apply absorption. It just takes training. We will aim to derive the missing link to apply hypothetical syllogism, the conditional if A, then A and B. And we can do that, we said, by absorption. So let's start. We can get the first subgoal by absorption from line 1. And now we can match 2 conditionals. We can cancel out the middle term by applying hypothetical syllogism. This will get us the conditional we want, if A then C. Given that conditional, we can match the antecedent of the conditional in line 3. We can derive not m by Modus Ponens. And now what's left is the final application of disjunctive syllogism to the disjunction in line 4 and negation in line 7. We got what we wanted, we're done. This time we are to derive the conditional if A then D, and we are given only conditionals in lines 1, 2, 3. That can seem problematic. We basically will need to apply the rules that take conditionals as what we need to have and allow us to infer conditionals as a result. There are 2 such rules: hypothetical syllogism and absorption. If you look carefully at the premises, you will see that we have a conditional with A as the antecedent in line 1 and with D as the consequent in line 3. But we can't apply hypothetical syllogism to these 2 conditionals because we can't match the middle term. Moreover, the antecedent of the conditional in line 3 is a conjunction, A and C, and somehow we would need to involve the consequent of the conditional in line 2. That's the only place where C occurs. But that conditional in line 2 with C as the consequent also has a conjunction in the antecedent, A and B. And if you look at premise 1, that's a premise where B is in the consequent. If we focus on premise 1, you can see that you could get the conditional if A, then A and B, and this would allow you to match the consequent with the antecedent of line 2, and then you'll be able to get if A, then C by hypothetical syllogism. Let's just carry that strategy out, and then we'll see what happens next. We apply absorption to premise 1. And now we can match the two conditionals in line 2 and 4. We cancel out the common term and get the conditional if A then C by hypothetical syllogism. Ultimately what we want is another conditional if A then D. D, as we mentioned, is a consequent in line 3, and we would somehow need to match the antecedent of that conditional, A and C, with the consequent of a conditional that would have A as the antecedent. In other words, we would need to get a conditional of this shape. But if you look at line 5, the one we've just derived, it's easy to see that we can apply absorption to it and get the conditional we want, the missing conditional to apply hypothetical syllogism. Now that we have derived that conditional, we can finally cancel out the middle term by applying hypothetical syllogism to line 3 and 6 and obtain if A, then D. We are done. I hope that you see that applying absorption can be a little tricky, but it's again all about your ability to see the relevant patterns. If you master the rule application exercises, you will be able to train your eyes to see the relevant patterns that provide the opportunity for you to applying absorption, and that will help you in the proofs. This is Logic Self-Taught. It's exercise time. Do all the exercises until they feel like a breeze.